This is Algebra Lesson 11.5, the quadratic formula. So, I said it previously that when an equation is in vertex form, we can solve it. We just drop the line algebraically, add both sides, divide both sides, root both sides, all that stuff. If it's in factored form, we can look at each of the individual factors and again solve those algebraically. If it's in general form, we can start by subtracting on both sides, and we can do that, but the next step, do I want to divide by this, but I can't do that because it messes up this? So do I want to divide by that, but I can't do that because it messes up this? Do I want to square root that? I can't do that because it messes up this. There's no way to solve an equation in general form. That's what we practiced, switching them to vertex form or switching them to factored form. But what we can do is use a fancy formula that will do all of the work for us as long as we know how to attack it with our order of operations. So, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I know I'm going to get yelled at for writing it sideways, but it works out a little bit nicer that way. We just need to remember that this is the denominator of a big fraction, so we need to put that in parentheses. We need to make sure our order of operations represent correctly. This is the numerator of a big fraction, so we're going to put that in parentheses, represent that appropriately. I'm also going to add an extra pair of parentheses underneath the square root. If this is written with all of those parentheses, you can really type this in one big giant thing on your calculator as long as you have, the appropriate tool, and it gives you your answer. It does all that work where we had to split our b term and square it and add it to both sides and then root that and then divide both sides. All that work in one big giant formula. So, let's try using this thing. First of all, you need an equation in general form, and that general form equation needs to be ax squared plus bx plus c equal to 0. If it's in that format, we can identify the a, the b, and the c terms of the equation. A is always the number in front of x squared. Well, if there is no number in front of x squared, I always call that the invisible 1. B is the number in front of x, and c is the number with no variable. I can plug those three values into my quadratic equation formula, and then I will have my two answers. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Type that out with a plus sign, one answer. Type that out with a minus sign, your second answer, and that's it. I am going to open up my calculator so that we can do this one and watch it happen. Okay, so parentheses for the numerator, negative b plus, and I'm just going to do plus, the square root of b squared. Oh, that parentheses after the square root on my calculator is automatic, so I'm not going to type a second one. Minus 4 times a times c. Now I close my parentheses once because that closes the square root. I close them a second time because that closes the numerator of my formula, divided by, and the denominator is, in parentheses again, 2 times 1. Now if you don't want to use all the parentheses, you can do your order of operations. You can do that by hand. We would do the multiply first in here. We would do the multiply first in here. We would do the exponent. We would do the subtraction. We would do the root. And then we would do the multiply here, and then we would do the add here, and then we would divide here. And it should come out the same as long as you're doing your order of operations correctly. But handy-dandy calculators are so handy-dandy. I got -2 for my plus answer. And look how handy-dandy this calculator is. I don't even have to retype it. I just have to change that plus sign to a minus sign, and I get my other answer. So I have x is -2 and -3. Let's do another one. I have a, I have b, I have c. X is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so x is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Uh-oh, non-real answer. I got 16 from 4 squared, and I have 40 from 4 times 2 times 5. 16 minus 40, that's a negative number, and I cannot square root a negative number. If you get error, non-real answer, it means no solution. I've seen other calculators say domain error, and I've seen can't square root 0. If that ever, or can't square root a negative, if any of that ever happens, that means no solution. If you see something that says syntax error, that means you typed it wrong. So don't just assume that every single error is no solution, but error, non-real answer, that's definitely no solution. I'll set up the next couple. I'm not going to finish them, but I'll set them up. And the reason I have these on here is because this one's not equal to 0. And so what you have to do is make it equal to 0. If something's on the wrong side of the equal sign, it means it's the wrong sign. I bring the positive 2 from the right side over to the left side, and now it's a negative 2. So I'd have a, b, and c in my equation. And I just make sure I got that negative in there. And that would come out correctly. I think I wanted this to be a minus because when you are putting your values into the calculator, x is negative b. If b was already a negative number, make sure you do the opposite of b right here. And then b is a negative 5, but there's a problem. On your calculator, when you square a negative number, your calculator actually gives you the wrong answer. But negative 5 times negative 5 is a positive 25, so that should be a positive. So my advice to you is to always put a negative in parentheses before you do it. So this is going to have extra parentheses there because we got the parentheses for the root, and then we also have the parentheses for the negative b. But the rest of it would be the same. 4ac, and then I'll just go all over to a. Yeah, that's about it. So, good luck on the exercises, and let me know if you have any questions.